Hello, welcome to another Teacher Tobin tutorial. We're going to be looking at the Edexcel GCSE Computer Science, topic 2, compression subject. And that's under specification 2.3.2 as a reference. Fortunately, in 2020, Edexcel simplified a little bit of this particular topic, because there used to be something called run length encoding, which was pretty tricky, that you don't need to know about anymore. It's not in the actual exam, so that's really useful. So the compression isn't too bad. So we'll go over like a big kind of exam style question, but it's relatively straightforward. Also, they have said that you don't really need to know about, for some reason, MP3s and MPEG, I think it's MPEG, as compressed formats. But I think it's worth covering it, because it just makes, because we use MP3 files all the time, and it's probably the clearest example that you might be familiar with about what compression means to you. So in the last video about sound, if we were recording, let's say, a 16-bit 44.1 kilohertz, so the bit depth 16-bit and the sample rate's 44.1 kilohertz, 3-minute track, we would be putting that on a CD as a WAV file. All right, an Apple, sometimes it might be an AIF file, AIFF, but generally speaking, a WAV file. Now, a WAV file is going to be uncompressed, but the file size is going to be bigger. So CDs were about 650 megabytes in total, and you could fit a full album on there, no problem. I know they've been superseded by other mediums, DVDs and Blu-rays, and now just digital files that are either streamed. But particularly with the case of streaming, that's why I'm talking about this scenario, is that when you're streaming a track from, say, Spotify or iTunes, it's nowhere near the same quality in most cases as even a CD file. It will almost certainly be a compression algorithm being used on it. And there are others, by the way. It's not just MP3 now. There are lots of other compression algorithms you can use. And also, if you're dealing with pictures, JPEGs are really typical image files that you'd be using. So these are two really commonly used file types that have been compressed. Now, there are two types of compression. And these are the two that you really need to understand the difference of: lossy and loss. Just type that again. Lossless. MP3, JPEG, MPEG files, they're all lossy compression formats, right? They go into this bracket because you lose information. Now, an MP3 file might be 10 times smaller than a WAV file. It might still be 16-bit, but there's going to be a lot of information that's been chopped away from that sample. It's not going to be as high fidelity as a WAV file. They might cut off certain frequency ranges, like below 20 kilohertz and above a certain range that you probably won't be able to hear. And there's lots of other complicated ways that they can compress and squeeze the information. But the important thing is that you have lost, if by going from a WAV to an MP3 file, you have lost information that can never come back. Right? You can't go from an MP3 back to a WAV. It just doesn't work. even though technically you probably could ask to export it as a WAV, but it won't be the same quality as the original WAV file. So JPEG is the same. If you've got a picture that you've taken from on your camera and it's uncompressed, right? I mean, I will just talk about some lossless formats like PNG, portable network graphics, GIFs. Other files like PDFs are usually lossless as well. They might contain compressed images and things inside, or .mov movie files instead of MPEG. Zip files. You can recover the information from those, no problem. There's no you're not going to lose any of the information. So let's say you just go back to your camera. You've taken a nice picture with your Canon mirrorless camera, and maybe you've got a raw file from it or a tagged image format, and then you process it in Photoshop, and at the end you might export out as a JPEG, right? That JPEG is going to be magnitudes smaller than those original file formats. Now you might want to keep those original formats for editing later on, but if you're sharing on the internet or putting on Instagram or something, that JPEG is going to be far more convenient. It's going to look pretty good. You're not going to notice a lot of the information loss, but if you're printing it out on a billboard, or if you're a professional artist, then you'll start to notice issues like maybe with the sky or pixelation or areas where it aren't as detailed as the original image would be. So a lossy format means if you compress to a lossy format, you will lose information that can never be recovered again. All right. Also, we looked at bitmaps. Bitmaps are lossless as well. Okay, so some of the disadvantages are detail lost forever, right? That you can never get it back. But it makes things like streaming videos or YouTube or Spotify exist, because there's no way those platforms would work by using uncompressed formats. It would just they'll be far too big, because lossy files are usually much smaller file sizes, significantly smaller, to allow streaming to happen, less internet traffic, less collisions, etc. So what could be the advantage of a lossless format? Yes, they are larger files, but no loss of data at all. We can recover from them. And even though run length encoding is not in the test anymore, thankfully, because it's quite tricky. Just to give you a little example of how compression might work, let's say you've got a very simple bitmap image of like an arrow, right? So anything that's a 1 might be a black, for example. What you have here is, yes, we have 1 pixel of black, but then we've got a group of 4 zeros in a row there. So it might be easier, instead of saying 0, 0, 0, 0, just to say 4 zeros. So I'm just abbreviating here, but you might have 1 and then 4 zeros, and then there's 1, 1, 1, 0, 1, 1. But in here, like for example, you've got a bank of 3 1s. So if you've got a bigger image with like lots of white space or lots of black, you can suddenly really cut down the file size by just saying all those pixels are white. You don't need to tell me what each one of them are, other than the fact that for like 80 pixels going along one side are all the same color, and it's much easier to write that in code, and that's how you can suddenly compress something really efficiently but not losing any data. You're just writing it slightly different. Instead of writing the value for every single pixel, you're saying, look, for the next 80 pixels, you're all the same. So you can put like 80 zeros, 80 white pixels, if you had a really big black and white bitmap image. And that's how you can like really create some nice compression, but maintain the original data. And zip files contain all the original data. It's important for things like text-based documents to not lose information. You do not want to be losing text fidelity or characters or content. So it's important for those type of formats. Portable network graphics are typically used for like logos and flat colors on websites. You'll typically find that the PNG, portable network graphics GIFs, are an older format which only has 256 colors, but they do animations, and they're also they used to be used a lot for logos and things like that, where you don't want to lose fidelity too much. So let's have a look at an example question, shall we? A musician wants to store hundreds of audio files to cloud storage, right? She wants to compress the files before she stores them. Compare using a lossless compression algorithm with using a lossy compression algorithm for this purpose. So I am a musician, and I'll talk about my own scenario here. The biggest problem here is if you use lossy compression, then you've lost information and it's difficult to edit those files later. So lossless allows, I'm just abbreviating here, work on projects at a later date. So let's say you've got a new song and you've got everything set up. If you were using a lossless algorithm, then it would allow you to save all of those stems, all of those files, all those WAV files that you've recorded, and then just edit them later on when you're ready. And you'll have no loss in quality. The original quality is going to be preserved. The sample rate, resolution. I mean, you can talk about things like bit depth, sample rate, resolution, okay, stays the same, just so you can really kind of make this a nice full answer. However, they are more complex and take longer. They take longer to run, okay. So that might be disadvantages. So that means they're going to take a lot longer to upload to the cloud, and it's going to take a lot more storage. Like I just ran out of iCloud storage, and I had a 2 terabyte iCloud account run out. Okay, I realized I had a lot of uncompressed images from Affinity Photo, which I've been using, which were like 300 megabytes each. And I thought, you know what, I'm going to put them onto a hard drive for archiving long term, take them off cloud storage so I'm not cluttering up my storage space. Plus they took a long time to either upload or download. So those are also things you could talk about, which is cost for me, because if I had to increase the cost of my Apple one about £27 a month to increase to 6 terabytes, I think it is. So those are already a lot of things that you can discuss to get your 6 marks. So just put yourself into a scenario. For me, musician, or maybe photographer, those are things. But I mean, of course, the question gives you the context already. But if you're not a musician, just imagine you were, and would you really want to be dealing with MP3 files if you're going to work on a musical project at a later date? However, what are the advantages of lossy formats? Like those MP3 files, which it doesn't state you need to say, but I'm just using it because that's the clearest example we have. Yes, you might have reduced bit depth or sample rate, for example, but better streaming. Okay, better user experience, because obviously the user, if they were streaming a WAV file on their 5G connection, it's going to be sluggish, it might jitter, it might be sort of cut out, it also take a lot of data. And they're going to get most of that experience just by listening to an MP3 without really perceiving the change in fidelity unless you've got a really nice hi-fi system. Most people just listen on headphones anyway now. So that's an advantage there. I think that would be enough. You could say quality of audio is reduced when using lossy algorithms. It may not be as acceptable. May not be as acceptable to the user. So I'm just going to put quality reduce. I'm not going to write full sentences here, but I'm just giving you enough information to go on. And you could also say, depending on the compression amount, users might not hear the difference. I think that's enough for 6 marks. There'll be enough things to talk about for 6 marks there. Just think about how you use audio and streaming services like that. Okay, so hopefully all of that helped and gave you a bit more insight into compression. As I said, luckily it has been simplified, because you don't have to deal with run length encoding, which is kind of my very simplified example of run length encoding was here, but you don't need to worry about that for the exam. But again, like most of these things, it's important to understand how something like that might work, because it gives you context for how you can have lossless compression in the first place. Right, let me know in the comments if you want more things like that, if you need more information on it, or if it's been helpful to you.